All right. So bell work there. I have a little bit of trouble with the way I'm supposed to do this. I'm supposed to give you the answer and then let you kind of, what's the word? Thanks for taking your earbuds out. I guess simmer with the thoughts and ideas behind it, and then if you would come back and we could talk about it later, like a one-on-one type thing. I'm still not there yet, so I feel the need to kind of have to do it with you still. The answer is no. The answer is no. This does not make a triangle. Now, one is, if you're the visual person, you can probably see them. Some people of us need rules, right? Now, here's what I know. I know one rule for a fact. I know that if I took those three and threw them in the Pythagorean theorem, that means that the longest side should square up with the two smallest sides, right? And do they?
No.
No.
They don't. Then there's that Pythagorean inequality, where if a squared and b squared, a and b being the smallest of the two, are greater than the longest one squared, then you would have what's called an obtuse triangle. And if they're smaller than, you would have an acute triangle. But in this case, we don't even have to go that far. If my longest side is 9 units, and I have one that is 5, and the other that is 4, don't 5 and 4 add up to 9?
Yeah.
That means that they would close on top of each other, making just another line. Does that make sense to you? Okay. And if you can't see it in your, let's kind of do this bit. I'm trying to grab my rulers here. So imagine that I had a 9 piece right here, and then a 5 and a 4, and they would just kind of line up, and they would touch each other, pop, and there would be no gap between them. So there would just be 2 lines on top of each other. Does that make sense? So no, this does not make a triangle. All right. So again, bear with me as I start transitioning into this new method. Over on the board. Actually, on my next slide too. So on the next board over there, we've got our purpose now. We have 3 things here to talk about. The content. This is what I want you to get out of today. One is to be able to use the law of cosines. Was that a sneeze?
Yeah. Who sneezed? Oh my god.
All right, anyways, thank you.
Are you recording?
Yes, I believe so.
Yeah.
So, our objective is that we're going to use a lot of cosines. Language-wise, we need to be able to use some of the content-specific language. Today's important ones are going to be the SSS. That's one thing that we didn't talk about last time. SSS, side, side, side. And then also SAS, side, angle, side. Okay? I think someone asked about angle, angle, angle. And we did side, side, side? Okay, cool, yeah. So, we did, huh? Because I remember whipping out the rulers. So, this is 6.2. Success criteria. I know that I can use a lot of cosines if I can use it to solve oblique triangles. And then we'll talk about Heron's formula as well to find the area of a triangle. So, it's another area formula, kind of on the side. It's called Heron's or Heron's. I don't know how to say that. No, this is 6.2.
I was like, wait a minute.
Okay, so there's our objective. Here's our success criteria. Again, language. Make sure that you know what we're talking about when we say side, side, side. And make sure you know what we're talking about when we say side, angle, side. Again, I'm going to push this one a little bit further. We're okay with talking. The talking should be content specific. And you should also be ready to come back to bigger conversation together. Okay, I think we talked about it before at professional courtesy. Okay, while we're in here, we're students first and foremost. Yes, absolutely. Let's get to it. Okay, so we kind of had this definition already for the last time we talked about solving oblique triangles. It just meant that you were finding all of the lengths of the triangle and all of the angles of the triangle, correct? Questions on that? Where did my notes go?
Where did they go?
Where did they go? All right, anyways, let's move on. Anybody need to write anything down from here?
No.
The law of cosine is going to be used mainly to solve triangles that give you SAS or SSS. So when you see those 2 scenarios, you should be thinking law of cosines. Did I put homework up last night?
Yes.
I was thinking about it at bedtime. I'm like, I forgot to do the homework. I'm like, Oh well. Good night. I've been very forgetful lately.
The homework made me mad.
I did the homework. Oh well.
I was sitting on the ground after stuff.
No, I fell asleep on question 4.
How was it? Not too bad?
It wasn't too bad.
There's just like some of the questions made me want to like punch my computer. It says off by 1.
Oh, sorry about that.
Some of them were like really confusing, like when you were trying to find like the grade.
The way they get worded.
Like
Well, after question 3,
so like I would do like the time, like the radian, like the decimal times the 180 over pi, but it would just give me the wrong.
All right.
Like it give me the wrong answer.
No, someone offered me an apple. I'm having coffee. I don't know. Hey, that's not funny. I'm like, that's a weird looking apple, literally. A cookie? Are you offering me a cookie? I'll have a cookie. Because cookies and coffee go bomb.
I want to get these. Those like
These are Girl Scout cookies. You're giving those away?
Bro, I got 2 boxes of
Thank
cinnamon
you.
saffron. I
Okay.
got 2 boxes.
Alright. The law of cosines, plural, there's more than one formula, but take a look at the way they're set up. They work very similar, don't they? If you want a squared, then you're going to have to equal b squared plus c squared take away 2bc cosine a. Let me finish up this good cookie while you write that down. And then I will tell you how I remember.
Dude, I love oatmeal.
Oatmeal raisin is bomb. I do not discriminate against any cookie.
You should.
Which cookies? Oh yeah, I like them. I do not dislike them. Molasses? I like them too.
What's molasses?
It comes from trees.
That's disgusting.
what about the macadamia nut cookies?
Even better.
Exactly right. My mom, everyone's like, ew, they're gross.
Hey, macadamia. All right.
Macadamia nut cookies are bomb.
Sorry.
Thank you. Here's how I remember. And if this works for you, great. If it doesn't, then figure one out, share it with me. But I always remember, okay, cosine is kind of like Pythagorean theorem. A squared b squared c squared. Do you see the a squared b squared c squared? Then you're going to take away 2 times the 2 that you added in here. See the bc? It's always going to be cosine of what it began with. So they kind of get recycled a little bit in there. And that pattern is the same for both. See how you have AC? We have AC there. And then it's the cosine of the other angle. Don't know if that helps. Don't know if it helps. If it helps, good. If it doesn't, then, like I said, figure out another way that does and then teach it to me so I can teach it to other generations to come. Oh, that sounded kind of weird.
It goes like this.
Oh my
I think it's weird because when I turned 30, my brother's still 15 years old. That's weird. That is weird.
No, that's how time works.
That's, I'm gonna be 30 years old. I'm like, oh look, my brother's 15.
Well, time doesn't stop for one person or the other, so it's like when I'm like, how old are my kids? So like when I'm like 49, my kids are gonna be almost 18.
My mom's 46 today. Today's her birthday.
That's how old my dad is.
Yesterday was my wedding anniversary.
My mom's 31.
How many years?
Technically, 13.
Why do you say technically?
Cause
Are
like,
you putting your dating years before?
right, well for no, married, like put a ring on it. We got married in 06. And we got engaged like a couple years before that. But like when I met her, like that was it. There was no other girl. So that's the way I see it.
That's so cute. That's adorable.
That's cliche. I met her at a wedding.
But your wife had a wedding?
How'd you
Pretty
start
much.
talking to her?
Wait, how old are you?
A friend of mine introduced us, like mutual
Did she
friends.
pass the flowers?
No.
Oh, okay.
I probably would have ran at that point. Alright, cool. If you need to go back, look at the recording. There they are. I cleaned it up. It's
Sorry, I'm struggling.
it's all good. Let's move on. Thank you. Here's what you want to look for when to apply it. Use a law of cosines to find the side opposite of a given angle. Opposite of a given angle. You guys remember yesterday I told you guys when you want to find the area of a triangle, and I gave you that sine rule thing, right? Remember I said look for this side angle side business, and that's a good indicator of being able. That's not even a triangle. That's embarrassing. Silence. I don't know. You guys remember I said, oh, if you see this side angle side situation, that's a good indicator that you can use that area formula.
Yeah.
Well, if you see this, that's a good indicator that you can apply the law of cosines to find this side right there, the side that is opposite to the included angle. Okay, that's what that's saying up the top. Once you do have that, then go back to the easy formula. Go back to the law of sines. Because the sines formula is easy, yeah? 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 Go? Yeah. So,
I'm shaking my head.
you know what? Shake your head all you want. I would rather use law of sines any day over this guy.
I don't even know
What's law?
I don't even know what.
Sorry, I was trying to make a point.
Wait.
Is that another
Write
fat
the law
joke?
of sine down, please.
The law of sine is 1/2 a different number.
No, that's the area one.
Oh,
The law of sines is little a over sine a equal a little b over sine b. Yeah, the easy one.
Yeah, well, I mean,
I would rather use that than the law of cosines.
Okay.
So,
Yeah.
now if you want to do more work, more power to you. You're welcome to use law of cosines all you want.
Wait, so we can't use law of sines instead of
Not here. Because remember, here, let's get rid of this real quick. I've got this situation, right? And I want to use the law of sines. So let's label some of these, okay? Let's call this A, B, and C. Which ratios would I select from this? I don't have enough information, right? I need 3 of 4 pieces here, don't I? Well, if I have 3 of the 4 pieces in those ratios, then yeah, definitely use your law of sines. But for this one, I don't have that yet. But that means that I can use the law of cosines to get little b here. And once I have little b, then I can go back and I can use my law of sines, which would be much easier to use than the law of cosines. Does that make sense? Huh?
so this triangle?
Drop the ball?
Yeah, it was like makes
Oh, I see. Oh,
Ohio State.
all right, cool.
Now we're gonna use this,
Hold on,
right?
your live is still trying to catch up.
Say hi to Mika.
Hi, Mika.
Hi, Mika.
I don't think he's on.
What are you doing, you lazy?
Leave your likes and subscribe.
What are you doing here?
Anise, you dropped the ball. You're supposed to say that. You're supposed to say it for us.
Hey guys, make sure you like, subscribe.
Yeah, I'm not.
Maybe you should go to
Mika, if you have a question, try using the texting feature. I opened it up, and we'll see if this will work also in the live session.
She's supposed to be watching.
I don't even know if she's watching, but I'll say it anyway.
We'll call her and tell her to get on.
All right? Good, good, good?
Young laugh.
Everyone's done copying their notes?
Yes.
All right, so with this in mind, how comfortable do you feel on a 0 to 5 scale? 5 means I totally got it. I don't even know what you're talking about.
Well, I'm
Two.
We got 3s? Okay. Let's go back a little bit because I see a lot of 3s out here. Okay? Here's a scenario. Thank you. Here's a scenario that I want to solve. I want to solve this triangle. That means I need all sides and I'm going to need all angles. My preference would be to use the law of sines. So, as I think about this, okay, looks like I have angle B, right?
Yeah.
But do I have little b?
No.
Do I have the measurement for angle A so that I can ratio it with 5?
No.
And I don't even have this angle either, do I? So the law of sines is just a no-go. I do not have enough information. Okay? That means that I'm going to have to use the law of cosines one time. Okay? Now, this is not an example. I don't know if it's going to work, so we'll do it anyway. And if it works, it works. And if it doesn't, then bleh. Okay? Now, this is little b technically, correct? That means that the version that I'm going to use is little b squared equals a squared plus c squared minus 2ac cosine big B?
Like.
Your thing is so crazy.
I had to think about it, but you see, I use my little rule there. I use my rule all the time. Okay. You guys good? Yeah. So I'm just plugging the stuff. I got B squared. This is going to equal, what's little a? 5? So this is 25 plus 9 minus 2 times 5 times 3 cosine B.
Wait, excuse me, sorry.
Cosine 36. Right?
Oh, thank you. What? Cosine 36 degrees. Okay?
Oh, this one's not all.
Wait, is that a 5?
That's a 5. That's A, and that's C. I plugged everything in. For the purposes, for myself, if you plugged all that in, and you wrote that on your test paper, and then you used your calculator, punch it all in and hit enter, that's cool with me. Okay? What'd you get?
37.83.
So little b, did you square root it?
Oh, crap.
Uh-oh.
Because that would not be a triangle, would it?
Hold on.
So it's like 6 something? 6 point. What'd you get?
6.15.
6.15. 6.15. So now I have little b. Little b is 6.15. Okay? So now that I have little b, now I have 3 out of the 4 to use the law of sines again. Okay? I don't want to try law of cosines again. Now if you want to do that, actually you wouldn't be able to because you don't even have another angle. Now you kind of have to go to law of sines, don't you? So we're going to go law of sines, introduce that, and find all the other stuff that we don't know. Does that make sense? Yeah, go ahead and write this down if you want. That's a good example. I just made it up. Yay, me.
I love how to.
What is your question, Anise?
I was just seeing if the thing works.
It does. Cool.
Oh my gosh, wait, I just realized we can watch it live on the speaker.
With delay, yes. I can't hear you. Yes, that's what the point was. Once you have something, in order to be able to fill in the law of sines, then you want to use the law of sines. Sometimes actually there's no choice. Even if I wanted to use the law of cosines again, I can't. Because I don't have a different angle, do I? So I have to introduce law of sines, and at that point, then I can pick whatever I want. But there'll be much easier work at that point. Okay? Thank you for putting your cell phone away. What's up? No. Facebook does not calculate for
I'm
you.
watching Netflix.
Oh, I thought you were over there. Was it you over there?
Yeah. So I did like a quick twice.
Are you in degrees or in?
Yeah, I'm in degrees.
Here's my second entry. What is it? Can someone verify? I already got a counter example. Can someone verify that this is 6.15?
No, it's 3 point like 2.
Okay, so I got a second here. 3 what?
It's not 3.2.
3 point. 3.2? Approximately?
One set.
Where did we go wrong?
I don't know. Someone gave me that number. I trusted it. So here, let's do this real quick.
18 times cosine of 36.
Ah! Infinity.
Do 18. Do 18.
Here, I'll let you do it.
So let's clear this.
Are you guys in degree mode?
We're in degrees. So we had 25
That's one.
plus 9.
They weren't.
Take away 2 parenthesis. What is it? 15?
5.
3 times 5, right? It's
Yeah,
15?
15.
15 cosine 36.
Yeah.
So is that, now we need the square root of that. Well, yeah, so it's about 3. So second square root of that
It was like
answer is approximately
I was
3.11.
in degree mode.
Okay, we're good?
Yep.
3.11? 3.11? No? Are you in degree mode?
Well, I mean, my brother has actually did that at the right now. I mean, I do.
Right, so you broke it here, and you did this piece. That's not the order of operations. Order of operations says, parentheses exponents multiply first. All of this is being multiplied. So you got to go 30 cosine 36, and then you can subtract that from, what is this, 34? So you can go 34 minus this, but you can't go 25 plus 9 minus 30, because there's a product in there. You see it? 3.11 is correct. 3.11 is correct, not 3.2.
I think it's 3.12. What is 3.12? It's 3.12.
Oh, I see you 812. How about that?
Okay, I mean,
Truncation. Truncation, por favation.
Wow.
We're good?
Yeah.
All right, let's do this for real. First example. Actually, you try this. You try this. I'm going to put a timer on it.
how dare you?
Put a timer on it. How dare you.
How dare they?
Remind me of a commercial for that. It's really funny. Yeah, it's a Dorito commercial. I don't know if you've ever seen it. Have you seen it?
What?
They accuse him of stealing all the Doritos. And they're like,
He's
you know,
why would I steal the Doritos? And he's like all over it.
yeah. Then he gets up. He's all offended. He's like, how dare you?
My favorite.
I don't need to sit here and take this. And he gets up. He's like, shh. Doritos everywhere.
My favorite one is the guy who's like, you missed the best part, and he grabs the other guy's fingers and just starts licking them. He said,
Oh yeah, I've seen that. That was kind of gross. Like, yeah, that actor should have paid a lot.
Bro, that actually
Oh my lord.
freaking Oscars. That was good.
Like, oh.
Someone else's fingers in his mouth.
He deserves an Oscar for that.
I know, right?
Oh, he tells good jokes out here.
Oh my god.
I'm just playing. You think I can make it? I feel like it's too much. Did I make it? Wait, that was way fast.
That was 1 minute.
That was not long enough. You need to relax there.
I'll play by ear then. Oh, there's a bell again.
Oh my goodness.
Saved by the bell.
I'm trying to write the question.
Nope, because Pythagorean theorem is for right triangle.
I don't know what side.
Oh, wait, hold on.
Oh my god, you can't hear me.
Well, first label the corners, and then that will tell you where the sides are supposed to be, correct?
Yeah, but
So here's what I do. Just draw a triangle, A, B, C,
Yeah.
and then put them where they belong. And you put everything where they belong. Now if you go A, B, C, it doesn't matter, it's the same thing.
So wait, do we have to find all the other angles too?
Solve it. It says solve the triangle shown.
So how do you fix
Area.
Can somebody tell
So
me
I think I got that right. Because then I got the
13.
I got
what they got for A?
this equal square root.
Okay, good.
So then after that, we use all sides to find the inside. I got 13. I got 13. No, the sine of
Got it.
13.
Oh my god.
9 is
Yeah.
over 7.
Wait, so we're
Think about it. It's a depth. 169 long.
And the other one, just do the normal one, simple equation, and then square root it. Makes it, that's alright.
What am I doing wrong?
Did you
There's
get
no
the,
way to
are you, oh no,
Even
you're
if
not.
it is, think about it. One is 7 and one is 3.
Yeah, I know, that's why I'm
It has to be somewhere around.
The nearest degree,
Not
so
even that. Because you have 27 and 8. They're just going to dangle.
it.
So you don't have to switch it separate. Yeah. Yeah, tell them what I told
And then from there, now you want to use all signs.
That's why you gotta use these formulas.
Or one of these, because once you know 2,
I gotta like that.
180 minus
I got
32.
13. I don't know.
Yeah.
It's
Look at us,
so-
we're done.
That would be.
I am the one, the one, the one!
My work. It's actually super nice. Yeah. Alright. Yeah, for your 2 degrees. Forgot the other one. You forgot to do equal parts.
You've only got one side. We're missing 2 more.
Yeah, just a little bit, just that way you just multiply it and get rid of it. You get signs by itself on each. Watch it, but you're on shit.
So my 3 different is going to be 8 times.
No, you flip both sides. Your door would be 8 times the sine of 20 divided by 20. That's just one. What?
I was supposed to do.
Yeah, none of them are negative. Are you in degrees already? Make sure he's in degree mode.
Yeah, no, we saw your face. I was like,
Oh shit, I figured you didn't know. I didn't do it today.
There's no tens, but there is
Yeah, it's just it's the notes from last night and the day and today.
Nah, because that's procrastination. That's bad.
Press answer.
Okay. Come back in 3, 2. Let's take a look at this. Let's break this down. We've got A, B, C. If you went A, B, C, it doesn't matter. You'll get the same thing. I know that the measurement here is 120 degrees. Little b, this is 7. And then I've got little c here, which is 8. That is the perfect candidate for the law of cosines because I don't have enough information to use the law of sines. That means that I'm after little a, correct? Correct. So the formula reads a squared is equal to b squared plus c squared take away 2 bc sine of angle A. Yeah. Thank you. Why am I don't know why I'm doing sine. It's a lot of cosines. Cosine A. I try to be cool. So, little a squared is equal to
64.
Is it 64?
49.
49
Plus 64.
plus 64 minus 2 times 7 times 8 cosine of 120 degrees. Who's got A for me? 13? Good. So you should get 13. There's your first checkpoint. Now, I said to you at this point, you really just want to go back to law of sines because it's easier, correct?
Yeah.
Doesn't mean you have to.
Why would you want to do this?
I understand. I'm with you. But some people can see things differently, and that's okay. I would prefer to go law of sines, but I want to make the point that if you still wanted to use the cosines, you could. Okay?
I want to.
Hey, there's nothing wrong with it. That's all the only point I'm making. Let's go ahead and verify, everybody. What did we get for the measurement of angle C?
32 degrees.
What's up?
Why are we figuring out C right now?
We need to solve the triangle. I'm not going after it. I'm just asking everybody what the answers are. Do you want to do one together specifically? Which one? What do you want to go after?
Angle B.
Okay, and we could have gone angle B or angle C. Doesn't really matter. You want to use the law of sines? Say yes.
Yeah.
All right, here's what I know for a fact now. I know that I'm going to use 13 or sine 120 over 13.
Yes.
Sine 120 degrees over 13. You wanted to go after B, correct?
Yeah.
So B is going to have 7. So 7.
No,
Oh, sorry.
other way.
Thank you. 7 sine B. Multiplying both sides by 7. Gone here. So that means that sine B is equal to some decimal. Some kind of decimal. Let's figure out what that is.
You get 0.466. 0.466.
7 sine 120.
Yeah,
I love the way it writes. 7. 7 sine 120.
Yeah, it's great, huh?
And then we're dividing that by 13.
Yeah.
So, Ernie, we've got this right now.
That's crazy, huh?
Um,
Like, nobody wants to come in. Everybody else.
So here's what I know. Thank you. So we know that the sine of some angle B is 0.446. That means that the ratio of opposite to hypotenuse simplifies to this. I want the angle, don't I? So I need to ask my calculator the correct question. What angle has 0.466 as its sine? Okay? So once you do that, it'll spit out the angle for you.
And then you get
And what's the angle?
28.
Is this the slide? No, wrong one. So what was...
You get 27.8, and then it tells you to round up to the nearest, so you get 28.
And that means that now that we have this 120, we can find the third one.
And once you go to the nearest degree, so it'll be 28.
Just want you to go highest degree?
Yeah, I just want you to go to the nearest degree.
Alright, so we'll go to 28. That means this has to be 32. Okay. Questions on any part of this?
I'm trying to catch up.
Nope. Sonny taught me.
Good.
8 equals
Thanks,
13.
Sonny. Right on. Yay!
I'm so proud of myself. Oh, whatever this was so good. I already know.
What?
Wait, can you go back real quick?
How about
Is that 6? Oh, is that code? Is that a 6?
right here? This says cosine. Sorry.
I was like,
It's because I wrote sine and it was little c, but then I made a bigger c. So it looks like a 6. Okay?
No, I got I It's so funny hearing your voice on here. Like, not funny, but oh my gosh. William, stop erasing stuff.
I'm not. I haven't erased anything.
No, I'm watching the live to catch up real quick.
No. No. We're not near it. We just spent a big block of time just doing one problem together, right? No, that's okay though. I'm gonna jump to Huron's rule, which you can copy down.
Oh my gosh.
And then we'll come back and do some more examples for the rest of the time. Does that work? Okay. No, that's not it. Here's what's really cool about Huron's rule, is that if I know all 3 sides of a triangle, I can find the area of it. What are you waiting for? Tell me. So, here, my friends, is Huron's rule, or formula. The area of a triangle is S times S minus A times S minus B times S minus C. Now, what is S? S is half of the perimeter. S is half of the perimeter. So that means A plus B plus C, take half of that. Okay?
Turn it down a second.
Oh, is there echo?
Yeah.
That'd be funny. Feedback loop. Yeah, isn't that cool? So here, do you guys have this copy down?
No.
No, of course not. Munoz, I'm writing in English, not chicken scratch.
I'm reading
Chicken English.
Are our numbers in English?
No.
What?
So are we writing in English?
No, we're writing in numbers.
We're writing it differently.
We're already math.
See, that's always been my argument. If math is a universal language, why are we not getting dual credits?
Exactly. Because I can't.
It's in English class. Well, okay, there's a lot of vocabulary in here, okay?
And then there's a lot of vocabulary. I'm
I
so
take 4
fascinated.
years of foreign language, should I?
All right.
I cannot wait for college. I can just take my AS.
Thank you. Thanks. Thank you. We good?
Yes.
Let's get back to this then. Let's apply this real quick. Here's what I know. What the hell?
It's just 1 half A plus B plus C.
Okay, thank you.
All right, cool. So I've got six sides. I've got 3 sides of a triangle. I know that one side is 6, another is 16, the other is 18. I want to find the area of this. Okay? So the area, first let's find S. S is going to be half the perimeter. So we've got, what is that? 22 plus 18? How much? 40. 40, half 40 is? 20. Now, the area is going to be the square root of 20 times 20 minus 6. What's 20 minus 6? 14. And then 20 minus 16. And 20 minus 18. There's our area right there. So what is this all?
47.
47?
47.3.
That can't be 47.
Oh, that's half the average.
No, this is the area, not the average.
Wait, how did you get
S is half of the perimeter. So add all these up.
It's 47.
Oh, this is 47?
No, that's 47.
the whole thing?
After the square root.
That's 47.
After the square root is 47.
No, seriously.
Cool. Thank you.
You're welcome.
I was like, that can't be 47. I mean, 20 times 4 alone is like 80.
Forget the square root.
What's the inside? What's the inside at least? Do you have that one still? What is it?
No.
2240.
Why can we say 0 but not 0?
Unless you're in the military.
Why do we call 0?
Round up.
I feel like New Year's was just for
Okay. That's the area. Isn't that cool? S is some variable that we need from Huron's formula, and it's simply half of the perimeter. So add up the perimeter and then divide it by 2. That's all S is. Cool. I told you it's different from this chapter. That analytic geometry is it's a toughie. It's a toughie. Okay. All right. It looks like there's only 5 minutes left.
Yeah.
Please do your exit tickets. I'm gonna turn this off and do the homework.